Hello, welcome to lecture 3. Today I am going to talk about trigonometry. This will be covered in two parts. So today I am going to talk on introduction to trigonometry. The second part will cover some application and exercises. So this is mathematics for class 10 based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. So we will begin with sine function from a unit circle. But before that, I want to remind you all that circumference of a circle which we have derived, it is nothing but 2 pi times the radius for any arc. And we have also shown that 2 pi is equal to 360 degree, pi is 180, pi by 2 is 90 degree and pi by 3 is 60 degree. These things will become more clearer as we proceed. So this is a circle of unit radius. Radius is 1. This is 0 to 1, 1 minus 1 minus. And this is the radius and this is a point P on the circle which you can describe by moving x distance and going up to y distance. So that's why it is written P of x comma y. Now this point will have a projection on the x-axis. This is called the cos theta which we'll see next, and there is a projection on the y-axis. This is called the sine. So this projection on the y-axis is same as from this here which I represent by sine. Now if you see that when this dot is here on the x-axis, y is 0. So projection on y-axis 0 but x is 1, and as I increase the angle I can see the projection on the y-axis will increase but the projection on the x-axis will decrease. So as this point moves towards this y-axis, the angle theta is now called pi by 2 because total angle of this circumference as I mentioned here is 2 pi, is 360 degree. So this will be 2 pi by 2, that is pi, and this is 2 pi by 4, that is pi by 2. Okay, this distance, this quadrant is pi by 2. So now when this theta becomes pi by 2, now you have the projection of this dot on the x-axis is 0 and the projection on the y-axis is full 1. So what I see is that when I move this dot from here to here, from theta equal to 0 to theta equal to pi by 2, I see that this projection, this one, goes from 0 to maximum. So I see here, I have plotted the same thing here, that when it goes from here, this is pi and this is 2 pi. Okay, from 0 to pi and 2 pi. So I see that when it is pi by 2, that is 90 degree, this one is maximum projection of y, and again when this moves here the projection will become smaller, and again at this point projection on y-axis will be 0. So when it goes to pi, so this distance covered is pi, it will go to 0. Then again it will, when this moves here, and it will have a minus 1 maximum. When it travels this 360 degree or 2 pi, the projection of this dot on the y-axis will again be 0. So you can see the sinusoidal, this function where it increases here from 0, then it goes to maximum, then again 0. This is one cycle. So in this one cycle, this cycle, okay, rotation. So here I have also plotted the same thing, that is, this is 0, then this degree angle is pi by c, this from this dot, this angle is pi by 3, this is pi by 2, and so on till it comes to 11 pi by 6, then 12 pi by 6 is 2 pi. So you see here I have drawn this line here. When it comes here, this is a projection on the y-axis, okay, the dot is here. Then this, when it comes to pi by 3, this is a projection. So this dot moves here, so y is increased. My y will then, when this dot moves to pi by 2, is a maximum, that is 1, value 1. Then again when it goes here, it will again come to this point, and so on and so forth. So this is a sinusoidal function. Now let us discuss cos function. Same thing here, I have drawn a circle. So the projection on x-axis we call it cos, and here we again see that when this point is on the x-axis, cos is maximum, and as the angle increases and goes to pi by 2, the projection of this dot on x-axis becomes 0. So when it is 0, unlike in sine function, the projection on y-axis at 0 was, when angle was 0, but here when angle is theta is 0, it is maximum. So it starts with maximum, and then when it goes to pi by 2, it is 0. The projection here is 0. Then it goes to minus 1 in the reverse direction, and then again projection when it comes to this point, that is 3 pi by 2, the projection becomes 0 here, and when it comes to again 4 pi by 2, that is 2 pi, the projection becomes again maximum. So here I have drawn a similar thing. This is the projection here. So when it is 0, it is maximum. Then when it's pi by 6, it reduces. When it's pi by 3, it further reduces. When it goes to pi by 2, there is no x component here, only y component is there. So here y is maximum, x is minimum. So this cos function is shifted by pi by 2. So because when sine of 0 is 0 and sine of pi by 2 is maximum, here cos of 0 is maximum and cos of pi by 2 is minimum. Okay, so it is shifted by pi by 2. So now we discuss a portion of a circle, and this is the circle taken in the first quadrant, and this is an arc from theta equal to 0 to theta equal to pi by 2 with a unit radius r equal to 1. This is the point. So once this point is there, so there are some trigonometric functions which we have discussed, two of them. The sine function, which is the projection on the y-axis, and the projection associated with the x-axis is called the cos. So I have written here cos. So these two we have discussed. But from this point, so there are a few other measures from this point. If you draw a tangential line, what does you mean by tangent? That is from this point and the radius is perpendicular. So it will only touch only one point on the circle. The distance between this point, the tangential point, to where it cuts the x-axis, I call it tan theta. And from this point P, it cuts the y-axis at R. I call this distance as cot theta or cotangent theta. This is tangent theta. And this theta is associated with this theta. Okay, this is the measure. We will, as we progress, things will get clearer to you more and more. And this is the distance from 0 to where it cuts. It's called the cosec theta. And from this 0 to this point Q is called the sec theta. So what we said was projection of ray P on the x-axis is called cos theta, and projection of P on the y-axis is called the sin theta. The tangential distance PQ from the tangential point P to the point intersecting the x-axis is called, this distance is called the tan theta, and from P to R where it cuts the y-axis is called cot theta. The distance OQ from the origin to this intersecting point here where the tangent cuts is called the sec theta, and from the origin this tangent cut the y-axis is called the cosec. Note here it is, this is your right angle triangle, and we know that hypotenuse square is this base square plus this height square. So cos square theta plus sin square theta is always equal to 1. That is, if I draw a right angle triangle, this point is a 90 degree and this is an angle theta. This is adjacent to angle theta and this side is opposite to angle theta, and this one, the longest side, is called the hypotenuse. So this hypotenuse square is equal to opposite square plus adjacent side. So now let us try to find the value of this trigonometric function for this given arc with a radius equal to 1. So for equilateral triangle, this green triangle I have here, this is theta is pi by 3 is actually 60 degree. So I can draw here. So I have 60, 60, and here this angle also, this green, this is a dashed line here, and this solid line, this green one. So this is the equilateral triangle, and all interior angles are 60 degree and sides are same. So I can say that cos of 60 degree or pi by 3 is equal to half. So how do you get half? Suppose this is 1, this is unit is 1, this also is 1. So it will cut at the half middle. So if you draw a perpendicular from this vertex, we have seen earlier. I don't want to repeat all this proof. So this will be 0.5. So cos of pi by 3 is half 0.5. And now once I have said that sin square theta plus cos square theta is 1. This condition is always valid for the right angle triangle. So using Pythagoras theorem, I can write that sin theta is nothing but 1 minus cos square theta square root of that. Okay, because this is square. So I write here square root of 1 minus cos square of pi by 3, and I know what is cos of pi by 3 is half. So I write here half square. So this is becomes 4. So 4 minus 1 is 3. So square root of 3 divided by square root of 4 is 2. So now I know what is sine of pi by 3. So I have found what is cos of pi by 3 is half, sine of pi by 3 is root of 3 by 2. So now we can find out tan pi by 3. This is the distance from P to Q is tan pi by 3. That is equal to, again I can say that this is the base, this is the height. So square root of SQ plus PS square. And I write here SQ, this is 2 minus 0.5 is 1.5, that is 3 by 2 square. Plus PS is, which we have found, PS square is root of 3 square is 3 by 4. So I have written here, that is 9 plus 3 is 12, 12 by 4 is 3, so is square root of 3. And this 3 by 2, we will see why this distance is 2. Next line we will see. Thus I can write tan pi by 3 is equal to sin pi by 3 by cos pi by 3. So here you see sin pi by 3 is root of 3 by 2 divided by 1 by 2, so you get square root of 3. So now, as I said earlier, that we will show you this distance is 2. So sec pi by 3 is nothing but, this is from this distance to this distance, nothing but PQ square plus PO square square root of it. Okay, so here I have written. So that is equal to PQ square, this tan square, that what we got is root of 3. So 3, so PQ is 3 plus 1, that's 4. Square root of 4 is 2. So here again we see that sec pi by 3 is nothing but this is 2 here, this is 1 by 2. So this is sec pi by 3 is 1 by cos pi by 3. The more further we go, we will understand it more. So this is one example I'm giving so that to make you understand what all this means. These are nothing but the distances here, like this is a sec, this is a tan, this is a cot distance from here, and this distance is called the cosec. But of course, you have studied in this earlier class that tan theta is opposite by adjacent. That we have already seen here. This is the sine tan theta. This is sine is opposite, and this is cos pi by 3 is the adjacent. Okay, opposite by adjacent. So slowly I am building up, just so that you can understand why it is called opposite by adjacent. This tan function. So I hope you are understanding. Have patience. You will understand in more detail slowly. Now we have to find what we have found: sine, we have found cos, we have found tan, we have found sec. Now we have to find cot. So now what I do is I use this triangle and this triangle, and these are similar triangle. You see here, this is pi by 3 angle here. This is 90 minus pi by 3, and this is 90. The sum of all the internal angle has to be 180. So 90 plus 90 and minus 1 by 3 pi and minus pi by 3 will get cancelled. So 90 plus 90 is 180. And here also you have 90 here. So this is a similar from the angle. So I can now take the corresponding side of the similar triangle, CPST, which we have discussed in class 9 and previous 2 lectures. So suppose if this is the base of the big triangle, this is the hypotenuse and this is the height. So height of a big triangle, and this is the height of the small triangle. This is a small triangle. This is the height of the small. This is the base of a small triangle. So if I take the ratio of this height, that is PQ by PO, here I have written PQ by PO is equal to base of the small big triangle, that is OP, and the base of the small triangle is PR. So here I have taken PO divided by RP. So now you see, when I have got this PR, then I know this is cot function I can get from here, and I know this what is the distance of PQ, which I have found is tan theta, that is root 3 here, and so root 3 by 1, OP is 1, again OP is 1 divided by RP is cot theta. So now I can get cot of pi by 3, I rearrange it and I get as 1 by root, and this 1 by root 3 is reciprocal of tan pi by 3. So I have written 1 by tan pi by 3. So cot function is a reciprocal of this tan function. Like we saw that sec is a reciprocal of cos function. Similarly, you can find now this one is left, cosec is left. So what I do is, so again I take these two triangles. So this is the base, this is the hypotenuse, and this is the base, and this is the hypotenuse. So I compare big hypotenuse is OQ by OR, and OP, this is the base of the big triangle, divided by PR. But I know what is PR. PR is cot theta. And cot theta I have found the value as 1 over root 3, which I put it here, this PR. And OP is 1, I know. OQ is the value of sec theta, which we have found above, that is equal to 2. And cosec theta we have to find. So I rearrange this one, and I get cosec theta as 2 by square root of 3. So now this 2 by square root of 3 is the inverse of this sine function, sine of pi by 3. So I write this as cosec pi by 3 is inverse of, or 1 by sine, or reciprocal of sine pi by 3. Now let us summarize this again. So this, we plot these functions. As I said, this is a sine function. It starts from 0. At pi by 2 it become maximum. The projection become maximum. And then at pi again, the projection of this on y-axis becomes 0. So this is a sine function, and cosine is the projection when angle theta is 0 is maximum. Here it is maximum 1. Then the projection at pi by 2 becomes 0. So this is a cos function. Similarly, this we have cosec. So suppose this is a cosec. The cosec, if you increase the theta, this is tangent. So now this, now cosec, when this point is here, when the angle is 0, so this will never cut the y-axis, so it will become infinite. So at theta equal to 0, it is infinite. And as you increase the angle from infinity, it will cut far away at y. And then as you keep on increasing, cosec function will come close to 1. See here I have given a animation here, so maybe it is not visible. This is the sine, no, this is cosine, this is sine, and you see this is a tangent cutting at x, and you can see it will be cutting here on y-axis is cotangent, and this you can see in this animation. So anyway, this animation can be understood from this figure also. So when this point comes to the y-axis here, theta is equal to pi by 2. Then you see this cosec function is 1. And again when it increases, you can see that again this value will increase. So minimum value will be 1, and from infinity it will come down to 1 and again go back to infinity. So this is a function. So similarly, you can see this is from theta equal to 0 to pi, and similarly from pi to 2 pi it will reverse. You can see from this figure, okay, it will go to the negative direction. And similarly for sec, okay, this is a sec. So for a second, when theta is equal to 0, for second, it will intercept at 1. Okay, it will intercept at 1. But when angle keeps increasing, so this, it will increase from here and it will go to infinity when it comes to pi by 2. Okay, so at pi by 2, it is going to infinity. And other way around also, when it goes to negative also, it will be the same. It will be very symmetric. So second is the distance from origin to this intersection point at x-axis, and cosecant is the distance from this origin to the tangential line crossing the y-axis. So this is, we have plotted it. And if you now see tangent, now this is tangent. In tangent, we know that this distance, when this tangential point comes here, so the distance between this and cutting the x-axis becomes 0. But as angle increases, the tangential point, suppose at this point it will be like this state, it will cut here, at this point it will cut here, at this point it is cutting here. So here from 0 it will keep on increasing, and if it is a negative direction it will be symmetric here. So at the tangential point cutting at x-axis at theta equal to pi by 2, it will never cut x-axis, so it will go to infinity, okay, at pi by 2. Similarly in the below also, here when it comes, it will never cut the x-axis, it will straight away go like this to infinity. Okay, so at this is your in the minus direction. And similarly cot also, you can argue it out similarly, that when theta equal to 0, cot will become infinity. So at theta equal to 0, cot is infinity, and when it comes to pi by 2 here, so cot will become 0. So at pi by 2 is 0. So when theta is greater than pi by 2 for cot, that is, say here it comes, then the value is in the negative direction, because I will show you that cot is nothing but cos x by sin x, but sine of minus x become minus sin x, that we will see. That's why it goes to the negative and it will become infinite when it comes to pi here, and this will repeat. So this is a period is pi, here period is 2 pi, this is here, then here. So this distance is from this minimum to this minimum is 2 pi, and here this is period is pi. Okay, now we will derive equation of a circle. This is x square plus y square is equal to r square. So this is, suppose given any circle of any radius, this is 1 or 1.5, and any point on the circle is represented by p of x comma y, where x is the projection in the x-axis, that is x is r cos theta, because cos theta is adjacent side by hypotenuse. And similarly y is equal to r sin theta, because sin theta is opposite side by the hypotenuse. So this can be of any r, and here I have written, if you substitute here x is equal to r cos theta, where theta I have taken as pi by 3, it can be any theta, and y is equal to r sin theta. So this is how you represent in trigonometric notation any point on the circle. So here x is equal to r cos theta and y is r sin theta, as we have shown here. So if I use x square plus y square, I get r square cos square theta, r square have taken comma, sin square theta, and we have told that cos square theta plus sin square theta is always equal to 1. So r square into 1 is r square. X square plus y square is equal to r square. Now how is cos theta defined? As I said earlier, cos theta is x by r, that is adjacent upon hypotenuse, and similarly y is y by r, that is opposite by hypotenuse, and tan theta is sin theta by cos theta. So this hypotenuse and hypotenuse will get cancelled, and you have opposite by adjacent. Now we will try to derive trigonometric table. So you take an equilateral triangle, okay, these angles are all 60 degrees. So if I divide this, if I draw a perpendicular bisector, 30 degrees and 30 degrees. So how do you find the height of this triangle? Again, I use the Pythagoras theorem. I take this half of this base, a by 2. This square plus height square is equal to a square, which I know, where I have written here. So h will be, I take this thing in the left hand side, it becomes minus a square by 4. And so you get height as root of 3a by 2. So once I know this height, now what is cos 60? Cos 60 is base a by 2 by hypotenuse is a by 2 by a get cancelled. So you have half here. So similarly, what is cos 30? Cos 30 is, this is the 30 degree I take from here. So this now becomes the base. So base is your root of 3a by 2 divided by hypotenuse a. So I get this root of 3 by 2. And similarly cos 45, I make a right angle triangle. And this is your base. Base is a. and the hypotenuse is root of 2 into a. So a get cancelled, I get 1 by root 2. So similarly for sine 60, again I take from here sine 60 is opposite by hypotenuse. So it is root of 3a by 2 by a. So I get root of 3 by 2. And again sine 30, I use this one here, opposite by hypotenuse. Opposite is a by 2 by hypotenuse a, I get half. And similarly sine 45, this is sine 45 is opposite a by root of 2 into a. So a will get cancelled, I will get 1 by root. So these are the trigonometric table which we can write. We will show it below. So just for a reminder, cos sec theta is, as I said, is inverse sin theta, and sec theta is again 1 by cos theta, and cot theta is inverse tan theta. So once I know this thing, I can get this value also, because I know that sine is sine and cos I have found from here, and tan theta is again is sin theta by cos theta, so I can get tan theta. So I can get all this relation. So this is the table here. This is theta in degrees above, and these are in radians. We will discuss what radian means, and I have discussed in class 9 in detail. But anyway, in a briefly, I will mention here also. So 30 degrees pi by 6, as I mentioned in our first slide. 45 is pi by 4, 60 degrees pi by 3, and 90 degrees pi by 2. So this is how it is. Okay, 0, then 1 by 2, 1 by root 2, root of 3 by 2. From here I put it here. Okay, see here I have written here sine of 0, projection on the y-axis is 0, which we have shown. Sine of 30 degree, here it is sine of 30 degree is half, I put it here. Sine of 45 degree, we have found it here, 1 by root 2. And sine of 60 degree is here, root of 3 by 2. So I tabulate here. And sine of 90 degree, that is, the point is on the y-axis, the projection is 1. So it is 1. So we know how to derive these values. And similarly, cos, you take it from here and put it here. And there is one easy way to remember this. Generally, I remember, I take this 0, 30, 45, 60 and 90. I write 0 by 4, 1 by square root of 1 by 4, square root of 2 by 4, square root of 3 by 4, and square root of 4 by 4. So 4 get cancelled, square root of 1 is 1. Here square root, 4 square root is 2, so square root 3 by 2. Here 2, this is 4 goes 2 times, so 1 by 2. So square root of 1 by 2 is 1 by square root 2. This is 1, this is 2 square. So square root of this is half, and this is 0. So similarly, you can do, once you know this, you just flip it, because as I said, it is there is a phase shift of pi by 2. So 0 will become 1, 60, this one will become root of 3 by 2. This is same, and this will come here. And once you know this sine and cos, you can find, you divide sine by cos, you get this. So you can get the full table, and cosec theta is actually your 1 by sine theta. Sine is 0, so is not defined. And similarly, here also tan theta is also not defined, because tan theta is sine is 1 by cos is 0. So 1 divided by 0 is not defined. So similarly, you can really write this table. So let us not waste time in doing this. You should try to work it out. Now regarding radian, so 1 radian is, suppose this is a radius of a circle. So 1 radian is an arc length which is equal to the radius of the circle. So here I say that length of 1 radian arc is equal to length of the radius. So the length of the arc which is equal to this radius is called 1 radian. That is the definition. And we know that 2 pi radian, this is your 2 pi radian, is 360 degree. That means 2 pi means 6.28 radian is 360, because this is pi is 3.14. So semicircle is 3.14 radian and full circle is 6.28 radian or 2 pi radian. So 1 radian is 360 degree by 2 pi. I get this 2 pi down here, and if you calculate this, you get 57.2958 degree. And arc length S, this is your arc length S. S is equal to r theta I have written. Okay, theta is in radians here now, because I can, how do you know that? Because fraction of circumference, suppose this is 2 pi, and this arc is a fraction of the 2 pi. So I write S by 2 pi r is nothing but this is a theta divided by 2 pi. This is a fraction of the 2 pi. So theta. So this should be equal. So now this 2 pi get cancelled. So S is equal to r goes here. So S is equal to RT. So here I have written here 362 pi radian is 6.28 radians. And similarly, area of a sector is a fraction of the area. This is area of a circle is pi r square. So this area, this shaded blue region, the area is half of theta r square. So how do you get that? The fraction of pi r square is the total area of the circle. So fraction of that, that is theta by 2 pi. I take the angle fraction of this angle, theta by 2 pi times pi r square. This is the area of a circle. So if this pi and pi will get cancelled. So I have theta r square by 2. So this is true only if the angles are taken in radians. You can evaluate the side of a triangle for a given right angle triangle very easily. Okay, that is hypotenuse square is equal to base square plus height square. But suppose it is not a right angle triangle, then as I has mentioned in class 9 also and in the previous lecture also, that you can break them into several right angle triangles, and then once you do this you get something called sine rule, that is sine A by A. Sine A is actually this angle sine A by A is equal to sine C by C is equal to sine B by B. So this is what I have written here. This is sine rule. So if you know the angle and side, and some angle and side is not given, by using this rule you can find the missing one. So how do you get this rule? It is very simple. So what we do, we find the area of triangles, these triangles. Say this triangle, this is the half base is half A times HA. Okay, here I have written. For this, similarly for this triangle, if with this base I take half base times HB, which I have written here, and half for this one from this base C, I write half C, this is half base times the height HC. So how do I find this HA, this is the height, and HB and HC, which are perpendicular to A, B and C. So I can write sine B, this is sine B is equal to opposite side is HA by C. Similarly, sine C, this is your C. The opposite side of it is HB by hypotenuse is A. So similarly, sine A is the opposite side is your HC, and this is hypotenuse is B. So I can write here and I rearrange it, and from here I can substitute here, and I will get AC sine B, because this is your C HAC sine B, and again for this is AB, because this is your base is here, HB is AB sine C, and similarly for this one it is here C is the base and HC is equal to B, so it is BC sine. And all these 2's which are there, because they are common, I can multiply by 2 and cancel all the 2. So I need not write by 2. So this is a sine rule. I can rearrange and I can get from here this 2 I get this, and from this 2 I get this. So this is a sine rule. So for trigonometric function to work, you need a hypotenuse, which you can only get in right triangles. When you are dealing with triangles other than right triangle, the solution is to draw a perpendicular line to create right triangles. Okay, this is the solution. So then you can make many right angles, and you can solve the problem. All right angle triangles have one right angle 90 degree, which we have said it is as 90 degree, and this is the opposite angle, and this is the side which is adjacent to this alpha, and this is the side which is opposite to alpha. So if I take this as an angle, then opposite side will be this and the adjacent side will be this. This is for the red dot, this red I have written. Okay, now as I had mentioned in my earlier slides, that this is a sine function goes from 0 to 1, and cos function goes from plus 1 to 0 at pi by 2. Here there is a phase shift of pi by 2. You take from minus pi by 2 to plus pi by 2. So sine of minus x, okay, if it is here, this is plus x, this is minus x, sine of minus x will be negative, and sine of x is this. But for cos x, you see whether it is positive or negative, you always have a positive value. So cos of minus x is cos x, we call it even function, and sine of minus x is always minus sine x. Now there are other identities like sine a plus b is sine a cos b plus cos a sine b, or cos of a plus b is cos a cos b minus sine a. So how do you prove this identity? For proving this identity, I draw a diagram, and this is your x-axis, this is your y-axis, and I draw this red line with a unit length. Here is from this point to this point is 1, and the projection of this point on the x-axis will be cos of this angle, and similarly projection of this point on the y-axis will be sine of this angle from this red line to this blue line. So now what I do is I divide this with a green line here. I draw one line here, and I call this angle the green angle, the green line, the angle between the green line and the blue line as A, and the angle between the red line and this green line as B, and this total angle is A plus B. Okay, so once I draw this, now if I draw a perpendicular from here, I take a projection here. This is your 90 degree. This I have drawn a perpendicular. So this projection will be, if I take a cos function, this cos of beta is your adjacent side by hypotenuse. See, if I call this adjacent side as x prime, so x prime, so cos b is equal to x prime by 1. X prime by 1 is x prime. So this is your cos b. So similarly, this will be your sin b, the opposite side of b. And what I do now is I drop a perpendicular line here. So it crosses here. So this angle, if suppose this is a, this is 90 degree. Of course, this will be 90 degree minus a, because 90 plus 90 is 180. This is minus a and plus a will get cancelled. So total internal angle has to be 180. So if this is 90 degree minus a, so this also angle will be 90 degree minus a. So now what I do is, if this is 90 degree minus a and this is 90 degree, so this angle has to be a, okay, because 90 degree plus 90 is 180. This is minus a plus a get cancelled. So its total internal angle is 180. So this angle has to be also this. So I know this is sin beta, this b, and this is cos b. So now this projection here will be your adjacent side. So this is cos a times hypotenuse, as we have done it here. And similarly, the opposite sides, this sin a times sin beta. This is hypotenuse. So you have sin a times sin b. So I know this distance and I know this distance. So this opposite side will be, this is your a. So it will be sin a times cos b. Okay, just go through it, freeze it. It is very simple. Now I have what here? This is angle a, this angle b, this total angle is a plus. So I know that cos of a plus b is a projection on this x-axis, which I have written here, which we have said earlier. And projection on y-axis is sin of, this is your, this from this distance, from this point to this point distance is sin of a plus b. So I have written it here, sin of a plus. So now this sin of a plus b is equal to this distance here. So what is this? This distance is cos a times sin b, and this distance is sin a times cos b. So here this distance plus this distance. So I have written here sin a times cos b, this one, plus cos a times sin. And similarly, cos a plus b is nothing but here the whole distance. Here it is, from here to here is cos a times cos b. How did you get this cos a times cos b? This is angle a. So adjacent side is cos a times the hypotenuse cos b. So this whole distance is cos a times cos b, because from this point I am taking it. Okay, cos b is up from this point to this point. So now this total, this distance is cos a times cos b. But then I have to subtract this much to get cos a plus b. So cos a dot cos b minus sin a times b, which I have written it here. So similarly, one can find sin of a minus b is equal to, I can write sin of a plus of minus. So this plus into minus is minus. So I get here sin a cos of minus b from this relation, plus cos a sin b. B is minus b. So this sin of minus b is minus sin x, or sin of minus x is minus sin x. So I have put here a minus. And similarly, cos of a minus b, again I write cos of a minus b, and cos of a and cos of minus b minus of sin a times sin of minus b. But this cos of minus b, as I said, cos of minus x is cos x. So cos of minus b will be cos b, and here sin of minus b will be minus. So minus times minus becomes. So these are the relation which can be proved very easily. There is another way to prove it. So we will show here another method. This is, you draw a triangle here, PQR, and this is you again, as I said, you divide this triangle. Okay, you draw up a perpendicular line from point P to this, and again you can draw a perpendicular line from this. These are the perpendicular, the symbol, this square. So what I do is, area of this triangle PQR is nothing but area of triangle RQS, this small triangle here, and area of triangle PQS. So area of triangle PQR is what? PQR is what? Half time base. Base is C, and this height is sin of A plus B times the hypotenuse. Okay, sin of A plus B times G. So this is the height. So half base into height is the area of this triangle. And similarly, area of this triangle will be half CD sin A cos B. That is this one. This is the base, half C times sin A times D times cos B. I take this height. Okay, I put it here. And similarly, for this triangle, I take half base, D sin B is the base, times D C times, because once I take here D C, here also I take D and C. CD cos A, this is cos A times sin. So now half get cancelled, and CD also get cancelled. So sin A plus B is equal to sin. So this is another way way of proving. As I said that you can devise your ingenious way to prove in geometry, but everything has to be logical. So this is quite logical. Now for a right angle triangle, so these are some identities, that is sine of 90 degree minus a. Suppose this sine of 90 degree minus a will be this opposite side AC, okay, AC by hypotenuse. So this will be also true for cos of a because adjacent by hypotenuse. So I have written sine of 90 minus a is cos of a. Similarly, you can show the rest of them. I will not go into detail. It's very trivial. Cos of 90 degree minus a. This is cos. That means this is the adjacent side of this angle. This divided by this hypotenuse. And similarly, sine of a will be this a bc by ab. Both are same. So I say that sine of 90 minus a is equal to sine a. So similarly, tan of 90 minus a is sine of 90 minus a cos. Cos by sine. Cos by sine is cot. Tan is sine by cos. And cot is inverse of that. So similarly, cot will be inverse of tan and sec will be inverse of 1 by sine. You just check it here. Cos sec will be inverse of 1 by cos. Okay. So just check it here. It is very trivial. If I do everything, then you will not do on your own. Now some example using this kind of identity. Evaluate tan of 65 by cot 25 degree. So I write this 25 degree as cot of 90 minus 65. But what is cot of 90 degree minus is tan of 65. Okay. Cot here it is no. Cot of 90 minus a is tan of. So cot of 90 minus this is a is nothing but tan of a. Tan 65 cancel, you get 1. These are all very trivial example, but we have to do it. Let us do it. Okay. If sine of 3a is equal to cos of a minus 26 degree, where 3a is an acute angle, find the value of a. So we know that sine of 3a, this is sine of a is 90 minus a. So this is a I am writing as 3a. So this is cos of 90 minus 3a. And this is given cos of a minus 26. So we know that this angle here and this angle a minus 26 degree and 90 degree minus 3a should be same. So now I just cancel it. I get this minus 3a here. It gets 4a and 26 I get it here 160. So a is equal to 9. So now we'll do some more examples. Many trigonometric problem can be solved using Pythagoras theorem. Okay, that is hypotenuse square is adjacent square plus opposite side square. Okay, these are all hypotenuse side, adjacent side and opposite side. Note sine and cos lies within plus or minus. Okay, so with this kind of understanding we can solve many problems. Like now example 1, given tan a is equal to 4 by 3, find other trigonometric ratio. The other trigonometric ratio means sine a, cosec x, sec x, cot x. Okay, so this, so sine a is what, so this is opposite and this is adjacent. So this is opposite 4 and this, and what is the hypotenuse? Hypotenuse will be 3 square, square root of 3 square plus 4 square. Okay, so that is equal to 16 plus 9 is 25. So square root of 25 is 5. So the hypotenuse is 5 here. So I write opposite. Sine a is opposite by hypotenuse. Cos a is 3 by 5. Similarly, cosec is nothing but 1 by sine. Sec is 1 by cos. So inverse reciprocal of that. So 3 by 5 becomes 5 by 3. And cot is your cos a by sine a. So it is 3 by 4. Now example 2. If angle B and angle Q are acute angle such that sine B is equal to sine Q, then prove that angle B is equal to angle Q. Okay. So if this sine B is equal to sine Q, then you have to prove that angle B equal to angle Q and BQ are. This looks very obvious, but anyway, we should prove. Maybe we should invoke this similarity condition and prove it. So let us see. So I take a triangle, okay, ABC and angle PQR. Now I assume these two are of a different triangle and we have to prove that this sine B is equal to, if this sine B is equal to sine Q, then we have to prove that angle B equal to angle. So since I have taken a similar triangle, I know that AC by PR is equal to CB by RQ is equal to AB by PQ, or other way around, PQ by AB is equal to PR by AC is equal to RQ by C. It's the inverse of it. Both are okay. So now here I have written here sine B is equal to AC by AB. Sine Q is here is PR by PQ. And since sine B is equal to sine Q, then I can write AC by AB is equal to PR by PQ. I have just rearranged it. And cos B is nothing but square root of 1 minus sine square beta, which we have seen. And cos Q is this. But sine B is equal to sine Q. So we say that cos B is equal to cos Q. So if cos B is equal to cos Q, what is cos B? Cos B is, here is adjacent side BC by AB and equal to here RQ by PR. Okay, the Q here. So this implies, again I rearrange it. This these two, and I can show that CB by RQ, this is CB by RQ is AB by PQ. I take this down, this fellow from left hand side will go up from denominator to numerator. So I get this, and AB by PQ I know is AC by PQ. So this is now what, this is a similarity condition. So these triangles are similar. So from corresponding part of similar triangle, angle B equal to angle. Now example 3, consider triangle ABC is a right angle at C in which AB is 29. This hypotenuse is given as 29 and BC is 21 unit and angle ABC is some theta. So determine the value of cos square theta plus sin square theta. This always has to be 1. Okay. Anyway, let us see, for given this it is 1 and cos square theta minus sin square theta. So here I have written AC is, we have to find this AC. So AC is your 29, this hypotenuse square minus, this will be 21 square. So I can write A square minus B square as A minus B into A plus B. So this is your 29 minus is 8 and 29 plus 21 is 50, 400. So this distance is 20. And we know that sin square is sin theta square and cos square theta is cos theta square. So now we know this AC is equal to 20. So sin square theta or cos square theta plus sin square theta, I can just substitute. Cos theta is your 21 by 29. So that is 21 square by 29 square. And sin square theta is your 20 square by 29 square. So if you take 29 square in the denominator as common, so you have 20 square plus 21 square divided by 29 square, and if you do this one you will find that 20 square plus 21 square is nothing but 29 square. So both get cancelled and you will get equal to 1. So similarly, kindly do this also. I will not do this. This also you can find. You will get some number you will get. Okay, now some trigonometric identities. Okay, we will use Pythagoras theorem, that is sin square A plus cos square A is equal to 1, which we have derived earlier also. Here I am just stating it. You divide by cos square. So this cos square A divided by cos square A become 1. This become tan square, and 1 by cos square is sec square. So similarly here you divide by sine, this one you will get here, if you divide this by sin square A, it is 1. Cos square A by sin square is cos square A, and 1 by sin square is cos square A. So just write it down in your notebook, all this. Okay, from here again you get, this is your sin square A plus cos square is equal to 1. So I take this to the right hand side. So sin square will be 1 minus cos square A. So sin A will be square root of 1 minus cos square A. So similarly cos square A will be 1 minus sin square A. Then you take a square root both the sides. Cos A is equal to this. And tan A is sin by cos. So you put this substitute here. And sec A is 1 by cos. So you can put this one here. And cosec is 1 by sin. So you can put this sin, the value of sin A. So these are the identities you remember. So, okay, now example 8.2.13. Sec A times 1 minus sin A, sec A plus tan A equal to 1. How do you prove this? It's very simple. Again, sec A I have kept it here, 1 minus sin A. And sec A is 1 by cos, sin, tan A is sin by cos. So cos A plus sin A divided by cos is common, so I write cos A. And now I have here A minus B times A plus B, that is A square minus B square, 1 square minus sin square A, and 1 minus sin square is cos square A. This is sec A is 1 by cos, so cos A and cos A is cos square A is here. So cos square A and cos square A will get cancelled because 1 minus sin square A is cos square A, that is equal to 1. Okay. Example 8.2.14, that is cot of A minus cos A is divided by cot A plus cos A is this one. So how do I write here cot A minus cos A divided by this thing I have written here. I have expanded this cos A by sin A and cot A again cos A by sin A. Cos A I have taken common, 1 by sin A minus 1. This cos A get cancelled. Now example 8.2.15, sin of theta minus cos of theta plus 1 divided by sin of theta plus cos of theta minus 1 is equal to 1 by sec. And you have to use this condition. So you are getting a, when they give some condition, then they give you a hint how to solve it. Okay, so now here it is uses square is there. So what I do is I write this one. This is I divide sin by cos. So this is tan theta, cos and cos get cancelled, minus 1 sec theta. Similarly down also. And I write this whole thing here. I just rearrange it here. And as I said, I can multiply and divide by, which we have studied extensively in class 9. So I multiply and divide by the same quantity, tan of theta minus sec theta and tan of theta minus 6. Both are same because it can get cancelled in one. So now I expand this. Okay. So once I expand it, I will get tan square minus sec square theta minus tan theta sec theta. You do it, that is tan square theta, okay, then tan theta sec theta tan theta, they will get cancelled, okay. So then you will have here tan theta minus tan theta minus 1 into minus plus sec theta, okay, minus. So you do it, these are all very trivial thing you have studied in 9th standard. Now you are all in 10th standard, so this all should be in your fingertips. So now I use this condition, that is tan square theta minus sec square theta is minus 1. This one will go here. So I write here minus 1 and minus tan theta sec theta. So now this is minus, I take it out common. So I will have plus 1 plus tan theta minus sec theta. So this and this will get cancelled. So I have minus 1 times this. And since this is minus 1, I multiply by minus here and again multiply by minus into minus plus. So this will become minus tan theta. Here is minus tan theta and plus sec theta. So sec theta minus tan. Okay, now to end this chapter, this trick which I have shown earlier in red, there is another better way that also I sometimes use if I don't have pen and paper. This is easy to do. This is, say you take a left hand palm and this, your little finger is 0 and this thumb is 90 degree. Then this finger, the ring finger will be your 30 degree, the middle finger will be your 45 and the forefinger will be your 60 degree. So if I label them, you write it down in your with your ball pen 0, 30, 45, 60, 90. If you write it down on your fingers, then it's very easy to find this trigonometric relation. So anything which is down, this, if they have been told what is sine of 30, one finger is there. So square root of 1 by 2. And if they are saying what is cos of 30, take the 3 finger up. These 3 are up. So it is square root of 3 by 2. Okay. So square root in the numerator, you take square root and always divide by 2. So if it is say cos 30, you take 3 finger up. This is square root of 3 by 2. So let us do one example. This is only, use it only for sine and cos. Once you have sine and cos, you can get tan. Once you get tan, you can get cot. Once you have sine, you can get cosec. And once you have cos, you have sec. Because inverse of cos is sec. Okay. So we only need to know sine and cos. Okay, so let us do for 45. 45 means you have to fold the middle finger. So you have 2 fingers down, this ring finger and the little finger, and 2 finger up of this forefinger and the thumb. So square root of 2 by 2. Always divide by 2. So square root of 2 by 2 is what? 1 by square root 2. Okay. So similarly, cos is also same thing. And if you want to do 60, then you have to fold this forefinger. So you have 3 fingers down. So square root of 3. So similarly, cos will be, if you fold this finger, you have 1 only up. So square root of 1 is 1 divided by 2. So it is 1 by 2. Okay. Thank you for this lecture. We'll again continue the second part on trigonometry. So trigonometry will be completed in 2 parts. So see you in next lecture. Thank you.